Okay. Hello, everyone. Welcome to sixth meeting of Deleuze Research Group here at Purdue. I'm Ahmed, and I will be the facilitator of this session. Today, we have Mike Ardoline from Louisiana State University, and we will be discussing his upcoming book titled Mathematics, Deleuze, Metaphysics, Difference and Necessity. First of all, I would like to thank you, Dr. Ardoline, for accepting our invitation and being here. We will start by Dr. Ardoline's presentation on his upcoming book, which will last about 45 minutes. Then we will have time for Q&A. So let me say a couple of things about Dr. Ardoline. Currently, Dr. Ardoline is a postdoctoral researcher at Louisiana State University. He'll be an assistant professor at the same university next fall. Congratulations for that.
Thank you.
And Dr. Ardoline obtained his bachelor's in science with dual major in physics and philosophy. After finishing his MA in philosophy at Kingston University in London, he completed his PhD in philosophy at Memphis University in 2021 with the dissertation titled Difference and Necessity, Dispositionalism, Deleuze, and the Finite Genesis of Transfinite Truths. His area of research includes 20th and 21st century continental metaphysics, speculative realism, philosophy of science, and mathematics. Today, we will be discussing his upcoming book. Please join me welcoming Mike Ardoline for being here today with us. We are very excited to have you here, Mike. So thank you. Thank you for accepting our invitation. And we can start with your presentation, I think.
Great. Thank you. And first, I also want to say thank you both for a wonderful introduction and for inviting me here to discuss my work. It's an honor. So thank you. So this book begins with two central problems. First is the question of how can a metaphysics that accepts difference as prior to identity, flux and chaos as prior to order, and becoming as the only form of being still affirm the status of mathematical truths as necessary, unchanging, and transfinite. Second is the question of how to reconcile the seemingly otherworldliness of mathematics with its indispensability to science and the various ontological paradoxes that indispensability raises. I see these two questions as fundamentally intertwined, and I argue that a satisfactory answer to one will answer both. So in short, to answer these, I use the metaphysics of difference developed in Deleuze's work to resolve a seeming contradiction in scientific ontology. Put simply, our best theories of the universe as a whole give the universe itself a birth date at 13.7 billion years ago in the Big Bang, and equally, they predict a death date for all things, the universe included, at 10 to the 100th years from now. While seemingly limitless compared to the span of a human life, these facts place harsh constraints on what sorts of objects could exist. The universe can only be made up of contingent, temporally bounded, and finite objects, and a finite number thereof. These constraints do not depend on the specific of those dates, they follow from the mere existence of a birth and death date to all things. The conflict arises when we take note that these facts are only available to us via mathematics. Without the application of mathematics to the universe, all cosmology would be nothing more than myth and conjecture. But when we ask about this tool, mathematics, it seems to commit us to all sorts of entities that could not exist within the constraints prescribed by physics. Take set theory, for example. There is a provable infinity of infinite sets, and that's not even all of them. And the truths about such sets are both necessary and unchanging. If we then include sets into our ontology in order to make sense of how mathematics is true, we violated the constraints of the physical universe and our best scientific accounts of it. If we do not, If we do not include sets into our ontology, however, it seems we cannot explain the truths of mathematics, and since we use mathematics to discover scientific truths, this equally jeopardizes scientific truth. Quine famously found this problem so vexing that it leads him to make an exception to his usual nominalist impulses and become, in his words, a reluctant Platonist. That is, Quine, who famously argued that a possible bald man in a doorway is too abstract of a referent to reason about coherently, ended up accepting a cascading infinity of sets into his ontology in order to make sense of the relationship between mathematics and physics. My solution follows a position which is the reverse of Quine. The rejection of abstract entities such as sets in favor of an account of modality that explains away the need for such entities while preserving the truth of statements about those entities. This position is known as modal structuralism in the philosophy of mathematics. However, I can't embrace it wholesale, as in its current form, modal structuralism replaces the posits of abstract mathematical objects with abstract logical objects or relations, such as possible worlds or entailment relations more generally. The latter is a problem because entailment relations themselves are necessary relations. And then they make use, so, and then this makes use of necessary relations to describe and explain these objects, and so it implies a contradiction. Hartree-Field famously attempted such a project where he logically reconstructs classical physics so as not to require quantifying over numbers and other abstract objects, but in so makes use of formal logic. My claim is that projects like that fail because formal logic itself is built on necessary relations, such as entailment, and therefore depends on mathematical machinery, such as model theory. If so, then a project such as Field's begs the question. It smuggles in, it pretends to do away with necessary relations, but it smuggles them in elsewhere. So we have then a problem of explaining necessary truths, and I argue that this problem can be solved by using different notions of both truth and necessity. This is where Deleuze comes in. I imagine a few eyebrows were raised above when I said that my account will do away with the need for abstract entities while preserving the truth of proposition about those entities. If such a claim sounds strange, it is because truths are generally thought to be made true through reference to what those truths are about. There are, of course, many different flavors of this, such as Quine's extensional Platonism or adequation theory of truth more generally. However, what they all have in common is an understanding of truth as representation. Here, I make use of Deleuze's critique of representation, where representation depends on some kind of similarity, identity, structural isomorphism, however you cash it out, between a representation and the thing represented. Deleuze's claim are not that such things as representations do not exist, but that they make up only a small subset of truths, and that representation depends on a prior process of expression. Before any representation is possible, that is, before any identity can be established, something must first be produced, must be first expressed. Before any, to take a simple example, before a sentence I say can represent a portion of the world, that sentence must first be said. This is true of even the most obvious representationally accurate sentences, such as the laptop is in front of me or profit is the exploitation of the work. Only once the sentence is produced, once it is said, can the sentence represent anything. In other words, what is said must first be different from what it is said about. Were it not, representation would be impossible because representation is, like all things, a relation of similarity constructed on top of difference. To attend to truth at the level of expression is to attend to both what is made true by constraint rather than by reference, and to what conditions that truth. Understanding mathematical truths at the level of expression rather than representation allows us to peer deeper than mathematical descriptions of the world into their operation and their metaphysical grounding. Importantly, both of these aspects are modal. How math operates is a question of what it can do, and what is mass grounding is a question of what makes those truths possible. Following this path from the conditions of truth to modality, we now turn to the fundamental metaphysical claim of this book. An account of modality must, roughly speaking, explain what can, what must be, what cannot be, and any complicated interactions of these categories. I argue first that what can be, i.e. what is possible, can be explained within the bounds of a scientific ontology by way of what objects exist and what powers those objects have. This is a position in analytic metaphysics known as dispositionalism. And while it is not the majority position, its account of possibility is relatively uncontroversial. Necessity, however, is taken to be an open problem for the dispositionalist, because the dispositionalist, at least one who is naturalistically inclined, as I am, maintains an ontology of contingent objects. So the question is, where does necessity come from in such an ontology? To solve this problem, again, I turn to Deleuze. Dispositions, I argue, can be understood in terms of difference. A disposition is a power to do something, and so a disposition is then a capacity of something to make itself different than it currently is, or to make something else different. Similarly, the objects which have these dispositions can also be explained in terms of difference. That these involve difference somehow seems uncontroversial. Following Deleuze, I argue that what has not been appreciated is that difference here is fundamental and positive. This notion of difference is referred to as pure difference or difference itself. It is this form of difference, I argue, that can explain the existence of necessary truths in a completely contingent universe. When I say difference is fundamental, difference must not be understood as a fundamental entity. This would run afoul of Heidegger's critique of ontotheology, with ontotheology being where all beings are misunderstood by comparison with some privileged being. So they take being itself as just one more being among others, but somehow is this privileged model to understand other things. Instead, beings, or objects as I prefer, are understood in their difference from pure difference. Objects have some identity or self-similarity. Pure difference does not. Pure difference, then, is what characterizes existence itself. Everything exists through difference, and so difference is the fundamental term in metaphysical explanation. This establishes, I argue, a relative necessity between existence and difference. Eventually, existence will cease, and difference will perish along with it, but until then, it is necessary that if there is existence, if there is anything at all, then there will be difference. Since this necessity is of a relation and not an object, it does not run afoul of our constraint that our ontology must include only contingent objects. That this necessity is relative rather than absolute is an important first step in answering the above questions. The truths of mathematics, as we generally understand them, are expressions of relative necessities. There are not mathematical statements that are absolutely true. Instead, there are theorems that follow from certain axioms. Given the axioms of Euclidean geometry, all of the derived theorems hold, and they hold necessarily. Nothing can be done to the world that would somehow make it so a theorem of Euclidean geometry did not follow from its axioms. But this necessity is only relative to those axioms. Modify the axioms to obtain a non-Euclidean geometry, and an equally relative necessity between those axioms and the theorems which follow from them will be established. They are all collections of entailment relations, and to ask which is more necessary or the more true geometry is a silly question. To claim one is absolutely necessary and the other geometries are somehow derivative is nonsense. That mathematical truth expresses relative necessity and the metaphysical priority of difference is necessary relative to existence gives us the step towards the claim that the latter can ground the former. If this was all we could say of difference, it would not give us much beyond the mere existence of a necessary relation. However, we can make a more robust claim. Pure difference has powers. This is what I mean by a positive notion of difference. A pure difference for Deleuze is inexorably making itself different. Since powers are the capacity to make different, pure difference then has powers. You'll notice here I'm struggling against the English language itself to not refer to difference as a thing or an object, but this is the inherent limitation of linguistic expression, at least in a language with the verb to be. So since one, difference has powers in the dispositionalist sense, and two, powers explain modal facts, and three, difference has its powers necessarily, then whatever follows from the nature of these powers of difference alone can equally be said to be necessary. I take this claim to be a modal paraphrase of Deleuze's well-known refrain that the form of change itself does not change. Necessary truths are then expressions of these powers of difference. And this takes us up to about chapter 1 of the book. The rest of the book explores the modal structure of the powers of difference itself, and to do so, the nature of difference is explored through Deleuze's tripartite modal distinction between the actual, the intensive, and the virtual. Here I follow such work as John Bowden's in separating these three aspects and taking intensity as in some way prior to the virtual actual divide. I also provide here a translation schema between Deleuze's modal concepts and the vocabulary of analytic metaphysics, pointing especially to the differences in the use of words possible, actual, and world between the two traditions. But with this in tow, it is then possible to seek out the powers and features of difference that can ground a transfinite number of mathematical truths and their status as necessary and eternal. These differential structures are 1, the generation of objects, 2, the production of time, and 3, a historical and contingent account of essences or multiplicities in Deleuze's terms, and 4, necessary excesses over these essences. Or here, I'll also talk about them as the structures of objects. Each of these accounts is its own chapter, and they are developed for the sake of explaining the other two seemingly otherworldly features of mathematical truth, that mathematical truth is unchanging, and that it has the ability to characterize infinity. For the generation of objects, I weigh in on the debate over individuation in modal context between Quine and Ruth Barkham Marcus. I argue that this debate is flawed insofar as it is limited to epistemological individuation of possibilities. My claim here follows from Deleuze's critique of possibility, in that in his account, possibility is not a metaphysical category, but an epistemic one that is only mistaken as metaphysical. If so, then distinguishing objects and identifying what powers they have, and so explaining what we can take to be possible, requires an account of metaphysical individuation, not just merely epistemic individuation or how we manage to pick out objects, but their actual creation and production, to explain how identity is possible at all. Here, individuation must be separated from two other processes: realization and actualization. Realization is the making real of a possibility, that is, of having some idea of what can be and making it so. Realization then depends on minds, and minds do not necessarily exist. So against the intuitionist, a Deleuzian cannot accept that minds could ground the necessity of mathematical truths. Individuation also cannot be confused with actualization, a mistake that Deleuze says would be as bad as confusing the virtual and the possible. Actualization is the becoming actual of the virtual. It is the manifestation of some power that already exists within or by way of the structure of objects. That is, actualization depends on the existence not of difference alone, but also on the existence of objects, and so depends on some existing identity. Here, I critique interpretations of Deleuze that claim novelty follows from the virtual, or that the virtual makes all things possible. Such positions are incoherent as they confuse actualization and individuation, thereby making novelty depend on a pre-existing power in the virtual, which would merely be another theory of possibility, the likes of which Deleuze critiques. Individuation positively characterized does not begin in the virtual, rather it begins from intensities, or pure differences. Pure difference is characterized as intensive difference, and intensities are best thought of as, like say, bits of pure becoming, as without identity or without fully deterministic characteristics. So not 90 degrees or 91 degrees Fahrenheit, but the movement from 90 to 91 degrees itself, that block of becoming, whatever that is. In interacting, intensities come to form connections. They resonate, they stabilize each other partially, and they open channels of transfer. In doing so, they come to form a continuity over themselves, and they become parts of a larger whole. This continuity is virtual, and if the process is completed, a new metastable structure is produced, an object that has a virtual and actual aspect. This is important for the project for two reasons. One, it establishes a power of difference to produce individuality. If difference itself produces individuals, then difference can ground processes that require individuals, such as counting and algebra more generally. Two, difference can also produce a virtual continuum. A continuum is required to ground truths about the real universe. This shows that difference itself can ground not just relative necessity, but actually not just relative necessity in general, but actually has the features needed to ground several fundamental aspects of mathematics as well. So difference has even more of the structure we need to ground mathematical truth. To account for the unchanging nature of mathematical truths, I argue that modality grounds temporality. So modality is metaphysically more prior than temporality. That is, time is made possible by objects with powers, particularly the powers to affect other objects and to retain the traces or inscriptions of such interactions. This is broadly an account of time as chronos in Deleuze's terms. And the structure of dispositions themselves as things that unfold over time also require there to be pure temporal difference, or what Deleuze calls ion. This account provides the conditions of possibility of time itself, since they are times, and since these are times conditions of possibility, they are metaphysically prior to time. Therefore, anything which is made true by these conditions of time must itself be unchangingly true, or at least they cannot change in time. I call these eternal truths to distinguish them from truths which are accidentally true of all time. But I do want to stress here that eternity dies with the universe, right? So I'm not saying that there is actually an unending eternity or an unchanging thing outside of time or anything transcendent. I'm making the claim that if there's something prior to time, metaphysically speaking, that would ground truths that are atemporal insofar as they cannot change in time. However, this gap between modality and temporality doesn't mean that, I should point out that this gap between temporality and modality does open up the possibility of atemporal change. And here I gesture towards what Deleuze calls static ontological. For infinity, we must look at the structure of objects and their relations. So these chapters were outside the reading for today, but I'll also give a brief overview to help tie the project together. First, the reason objects become important at this point is that difference itself cannot ground infinity. In other words, the universe could not individuate an actual infinity or an infinite number of things. If it could do so, then it would be capable of producing something with the properties of a fundamental identity, and so this would contradict the priority of difference itself. We could perhaps say that individuation does not have a limit, and so could ground a potential infinity of things, but that would merely give us a countable infinity. The virtual continuum of objects argued for above already gets one cardinality higher than that, in that it can ground an uncountable infinity, that is, the real numbers or the continuum. So from this, I critique interpretations of Deleuze that uncritically use or invoke the infinite in relation to his work. I argue that Deleuze only ever uses a qualitative notion of infinity, not a quantitative one, and that the affirmation of real quantitative infinity would contradict the fundamentality of difference itself. This is seen most directly in What is Philosophy, where Deleuze and Guattari reinterpret set theory to be not an account of the infinite, but as a formal theory of the relationship between the determinate and the indeterminate. And so transfinite truths cannot be grounded by difference itself, but they also cannot depend on the properties of any specific objects. All objects are contingent, but transfinite truths are necessary. Instead, we can look for the grounds of transfinite truths in the structure of objects as such. Such structure depends on powers of difference itself to give rise to objects, and so such truths are relatively necessary to the relative necessity of difference itself, because they're grounded in the power of individuation again. I argue that the mathematical machinery which lets us derive truths about infinities are, in reality, expressions of the various relations of excess which are part of the modal structure of any object. The mathematical machinery required is the notion of sets as a completed infinity, the axiom of infinity, and the power set axiom. These are the required pieces to prove Cantor's theorem, which informally states that given a transfinite set of certain cardinality, one can always use the power set the operation to produce a transfinite set of larger cardinality. Even more informally, for whatever infinity you could specify, there always exists a larger infinity. These excesses, which these mathematical facts express, are those of an object over its parts, of the relation between an object of its parts, of the excess of the parts over the object, and of the environment over the object's own integrity, or of other objects over a single object. First, the structure can ground truths that completed infinities, not merely potential infinities, because each object is an individual, so like a completed thing with boundaries, that contains a virtual continuum. This follows from the excess of an object over its parts. Second, The axiom of infinity in set theory defines and asserts the existence of an infinite set as a set which can be put in a one-to-one correspondence with at least one of its proper subsets. For example, the even numbers are a subset of the natural numbers, but the even numbers can also be used to count the natural. This is grounded in the virtual relations between the internal parts of an object and the objects actually playing the functional role of those parts. Finally, the power set axiom describes an operation whereby a power set is derived from a set that contains all possible subsets of that smaller set. The power set of an infinite set is always a larger cardinal. This is then grounded in the fact that an object may relate to parts of another object in a way that exceeds that object's own relation to its parts. That is, object 1 relates to the parts of object 2, such that it overpowers object 2's ability to hold itself together and can potentially rearrange those parts. Imagine the way a hurricane may relate to the parts of a car, tearing the car asunder and chaotically rearranging its parts in a wild variety of possible ways. As long as any object exists at all, such relations remain possible, and so it is a relative necessity ensured by individuation, the powers of difference from the powers of difference capable of producing the structure of objects. Since these excesses are only ever of finite objects over finite objects, they do not require us to posit any real existing infinities. However, their structure allows for the expression of truths about infinity. That is, Cantor's paradise of an infinity of ever-ascending infinities is really an expression of the deep truth of the contingency of finite objects. If this systematic reconstruction of Deleuze's metaphysics stands, then it accounts for the seemingly otherworldly quality of mathematics in entirely this worldly terms, those being powers and difference. Furthermore, it explains both the surprising qualities of mathematics as well as their centrality to the sciences. Science aims to predict and understand what happens in the universe, and what happens in the universe is a result of what powers there are, of what objects exist in the universe, and of the powers of difference itself. It is mathematics, then, which studies the powers of difference itself, and so studies the very limits of what happens in the universe in which we find ourselves. So in short, my claim is that what mathematics studies is the modal structure of difference itself. Thank you.
Thank you for this great presentation. So it's a time for Q&A. If anyone has questions, they can either unmute themselves or send their questions to chat and I can read it. Yeah, Arkady, please go.
Okay, Michael, thank you very much. I have some questions, something which you never mentioned. Well, first of all, you mentioned as a fact that it's established that universe not only was in a Big Bang, but will collapse back, which is, by the way, is not established. That's a hypothesis, and in fact, more commonly challenged than established, to my knowledge, right? It's because it's quite possible that it will continue to extend without collapsing back. But that's not so much germane to the argument. A more complex question is that you mentioned that that existence of infinite number of infinities is a mathematical proof, which is also a question because of the undecidability of the continuum hypothesis. Technically speaking, that statement would be undecidable. There is really no proof that infinity would strictly be defined by power axiom in a sense that even continuum is necessarily bigger. So technically speaking, you never mentioned actually the undecidability, and it's interesting because Deleuze and Guattari, I think, tend to be most of the statement concerning undecidability. I remember from them or no, even though they rarely refer to Gödel theorem, are kind of on a more negative side. They don't seem to like undecidability, but I think some of this mathematics which you mentioned would clearly be challenged by undecidability. In fact, there are views which are quite legitimate, including by Cohen, who prove the undecidability of the continuum hypothesis, that in fact it is just false, that there are no infinite infinities of mathematics. And in fact, there are even views that there is no infinite objects in mathematics. I think so some of these views are challenged. Actually, I wonder what is your what is your reaction to that? Obviously, people like Wine don't comment on that type of dimensions, but they exist. I mean, certainly the undecidability of continuum hypothesis is a mathematical fact as good as any. Plus, of course, there are other axioms, not only that the power axiom is an axiom, it's clearly manifested for any finite set, but its significance for any infinite set. In fact, continuum hypothesis that's undecidable. So I think it's not necessarily applicable. Plus, you have an axiom of choice. All these things are axiom, many of which have been challenged in mathematical logic. Most of the practice of mathematics obviously doesn't depend on that. You know, I can do all the geometry I want, Euclidean or non-Euclidean, without worrying too much about that. But I just wonder what is your thinking about this aspect of the situation, on which, you know, you seem to be taking some of these things a little bit for granted.
Yeah, great. So a lot of different formal results to talk about there, and various debates in different scientific and formal fields. So first, I will say, yeah, there's other models of the universe that are, you know, infinite inflation is a model. There's multiversal models. There's all of these different models that there's an eternal universe, that there isn't that there isn't an end date, that the Big Bang isn't actually the beginning, that there's all of these different cosmological models. Which one is the most preferred currently, or the one that people are most likely to bet on? I've noticed really seems to change depending on who you ask and who you're talking to.
Yeah.
If you're talking to cosmologists, they seem to be more, at least the ones that, like, you know, mathematical cosmologists that I've met seem to be more on the side of an infinite universe. But if you ask like working physicists, people working on quantum mechanics, some astrophysics, then I seem to find more the standard picture is there's the Big Bang. There will be we have reason to believe that there's positive cosmic expansion. So the universe it won't crunch. I didn't mean to imply that ending, but that it will just tear itself apart at a certain point, you know, 10 to the 100th years from now. Or not 100th, 100 years from now. But that is effectively still the destruction of any possibility of existence. You know, subatomic particles tear themselves apart at that point, and that's, I think, for my purposes, that is enough to establish contingency of anything that exists. And there, like I said, I don't want to be wedded to any particular cosmological model. I do think that the history of science, the history of physics, has been the history of replacing presumed infinities with more complicated finite structures. And this is why I generally don't trust eternalist pictures of the cosmos or any sort of infinite picture of the cosmos. I could be wrong about that. That's an empirical thing that could undermine this project, but I leave that one up to the scientists to figure out. As for the formal results in mathematics, so the undecidability of the continuum hypothesis. So Gödel proves that it doesn't follow. Cohen finishes the proof, shows that it's independent from Zermelo-Fraenkel and just, you know, axiomatized set theory in general. Well, most of the common ones. But that doesn't reject Cantor's theorem, right? So Cantor's theorem is the establishment that there will always be, you can always derive a higher cardinality of infinity given an infinite set. The continuum hypothesis is about the ordering and about whether or not there's an infinity in between the natural numbers and the real numbers. If the continuum hypothesis is true, there is no infinite cardinality. There's no cardinality between those two. So the natural numbers would be the first size of infinite set. The real numbers would be the next size, the power set of the real numbers, and so on up. Or at least that would be the the generalized continuum hypothesis would be that the power set relations track the relations of cardinality. Now, that's not proven. In fact, that's independent of current axiomatizations, but that's only a point of order and a point of whether or not we should believe in intermediate cardinalities. It doesn't challenge Cantor's theorem that given an infinite cardinality, you can always produce a larger cardinality.
Well, that's not true. If you don't have, because this cardinality may not be continuous by continuum hypothesis. So therefore, it poses a problem of that type. If you don't have continuum hypothesis, the next cardinality will not be continuous. So I think it's really unclear what kind of any infinity beyond countable infinity will be produced.
But if you accept the axiom of infinity, which just says there exists a set that can be put into a one-to-one correspondence with one of its proper subsets, and you accept the power set operation, you get the cascade, the Cantor's like upward cascade of infinities.
But there is only one
continuum hypothesis would only establish whether or not there are cardinalities in between those.
I have to disagree with that, even though it's too long to discuss, because if there is only one order of infinity which is countable, you don't have the infinite hierarchy of infinities beyond that. So that's a somewhat different issue from claiming that there is an infinite number of infinities. See, there could be an infinite number of sets, but it's not the same as to say that there is an infinite number of infinities.
So, but let me say that if that turned out to be the case, if you were right, that would actually make my job easier. Because my claim is that you can have truth makers for infinity in a finite universe. If I don't have to explain all of those Cantorian infinities above the countable infinities, then I just have less that I have to explain. But I will say this in defense of still trying to explain them. I take this work to be attempting to explain any necessary relation, including necessary relations between formal statements, so entailment relations, and whether you take there to actually be infinite sets or infinite cardinalities or not, you still get truths about transfinite sets larger than the continuum. And so if there are truths that follow from certain axioms that just have necessary relations, so there are theorems of axioms, then I still have to explain how it is that that entailment relation between those axioms and theorems could exist. How could there be a truth there? That's broadly what I take this to be doing, because I'm agnostic on the question of what is the proper way to do mathematics. I think that's a question for the mathematician. I think this project actually requires commitment to a mathematical and logical pluralism. And so if someone wants to be an ultra-finitist about mathematics and say, look, we should come up with systems that are just completely constructible, that don't have any of these Cantor hierarchies, great. But you still have to explain why are there well-behaved formal systems that have. And that's what I take this project to be doing.
You still have to define continuum, which is impossible in view of the Gödel theorem. The continuous infinity is undefinable. That's the problem. Okay.
Thank you. We can take the next question. If you are raising your hand on the camera, I cannot see. You can either use the raising hand function or just unmute yourself. And if no one has any question, I have a question. Maybe I can go for it. So I think right now no one has any questions, so I am asking my question. So my question is kind of basic. So it's about your definition or your take on the term object. Mm-hmm. So you define an object as So here's a quote. You say on page 78, the structure of an object is what it is because of the differential relations between its dispositions. So, and you retain that terminology of object and dispositions throughout the book. This is one of the main terminological tools that you are using. So my question is just in general. So if an object is this, not sum, but is let's say sum for now, some of its differential, some of the differential relations that grounds it, it's like which are its dispositions or powers. So to me, it seems that in your project, these dispositions or powers are never fixed. So they are always in, or at least in Deleuze. So they are always in this flux and they are changing. So you cannot fix a certain set of dispositions or powers that define an object with a certain contours. And I think you would agree with that because that would create a kind of necessary object, and you deny that. Or I don't know about this, but the thing
Could you,
is,
sorry, could you repeat that? Like, I think yeah, I think I missed part of it.
so yeah, I was saying that, so I think in your project, or at least in the scope of Deleuze philosophy, so these powers or dispositions that define an object are never fixed, because if they are fixed, they kind of define a necessary object. I am not sure about this, but that's okay. This is not really important for my question. So the question I am getting at, like, trying to get at is, so if these powers or dispositions are never fixed and they're always in this process of becoming, how can we really talk about objects, or do we need this terminology of objects? And Deleuze does not use that, like, right? So he uses hexades or becomings, so you prefer that terminology of object, which is fine, but just I wanted to just hear your reasons and like philosophical justification or reasoning behind that choice.
So normally I would punt here and tell you to read Arjen Klein-Herenbrink's excellent book, but I know you've already done that in this reading series, so I'll have to give my own independent defense. So my claim here is that if you just have this idea, if you have this reading of Deleuze that everything is constant flux and process and change, and there's nothing that you can talk about as a sort of stability, or there's nothing you can talk about as metastable, or something like that, then you cannot distinguish individuation and actualization, right? Because you need to tell me some difference between those two processes. In Difference and Repetition, Deleuze says twice that confusing these two processes is as fundamental a mistake as confusing the virtual with the possible. So my claim there is, well, look at what each is doing. So actualization, get a pretty clear account of it as a form of differentiation where you're moving from the virtual to the actual. So something that is structural, something that is, I don't want to say powers or capacity, something that is indeterminate, that is part of like this impulse or ability that the object has, becomes a manifested quality. And a manifested quality spread over an extension. So it becomes something determinate that's currently manifest. And that sounds like, okay, there's something following from a structure that's giving a current manifestation, and that can change, but that can change while whatever is doing that stays broadly the same structure. Now that structure can change, things can be destroyed, things can be undermined, but if actualization is a process happening in something, then there is some structure staying relatively stable. Not immutable, not unchangeable, not essential in the classical sense, but is at least structured and metastable. What then would there be for individuation to explain? Well, if you look at the account of individuation, it doesn't begin with the virtual the way that actualization does. It begins with the intensive. And rather, I should be clear, I kind of go back and forth on using the phrase the intensive and intensity. And I should clarify, I mean here intensity. Because if I talk about the intensive, I like to mean that's sort of a feature within an object, but intensities are just pure differences, not within or not reference to some object that they're the intensities of. But the account of individuation begins with intensities. So it starts somewhere different than actualization, and it doesn't end with a current manifestation of qualities and extension, which actualization does. It ends with the production of some metastable structure, right? You know, look at individuation as Deleuze is getting it from Simondon. It's the creation of some stability, some metastability that has a structure that persists for some time, and in doing so can be identified. It's not a fundamental identity. It's not an eternal, unchanging essence. Its possibility and its identity do not pre-exist it, but they do come into being with it. And so there, what I want to say is, well, okay, if we're reading Deleuze right, we have to keep these two apart, and we have to be clear what is being produced in each case, right? Actualization produces actualities, produces qualities over extensions. Individuation produces an object. And if we have that, then we actually get, I think, something more meaningful and more structured than a simple all is flux view, because we can actually make sense of the stuff in Anti-Oedipus, where Deleuze and Guattari are constantly talking about not just flows, but breaks. You know, flow and a break, right? And if you have these productions of metastable structures, if you have these productions of objects, then you have the thing that can help explain the breaks.
Yeah, that makes sense. Just I agree with that. Agree that like in Deleuze, it's not all about virtuality. Like objects cannot be reduced to this virtual aspect. But just maybe as a follow-up, because I think that like yes, you can fit that terminology of objects, and for instance, like the terminology of object kind of comes with the terminology of subject, right? And like Deleuze wants to undermine that relationship in some way. I think he's not thinking that, oh, these discrete objects can be explained only through virtuality or intensive relationships. He thinks that these are real, like as much as their representations are. But the thing is, they are produced through this intensive relationship. So they are secondary in a way. Objects are secondary as much as subjects are secondary. They are productions of these processes of objectivation or subjectivation. So, and I don't think that you are disagreeing with that. I think there's nothing to say. Just this terminological choice on the part of you was kind of intriguing me throughout the reading of the book. So yeah.
I would say one of the projects of the book is I think there's broadly two ways to approach terminology in history of philosophy, right? And I'm sure there's more, but there's two like major poles. One is the constant coining of neologisms, right? The making new terms, the inventing new vocabulary. And I think Deleuze and Guattari did that way better than I can. But then there's a thing that you see really adroitly done in Spinoza, which is the capturing of old vocabulary, redefining it, and turning it against its old projects. You know, the way Spinoza redefines God, redefines blessedness, takes all of these terms that you might see as somewhat philosophically outdated even when he's writing, or might seem as like, hegemonic or whatever you want to call them. But by putting them into the system, by redefining the way he does, makes something new out. I thought the best I can do, if Deleuze and Guattari are better at the neologisms than I am, what I could do is I could take Deleuze's metaphysics and re-express it in terms that classical philosophy is more likely to accept, like object, like essence, like eternity, but in doing so, change those terms and sort of try to steal them away from these more classical philosophical uses.
Thank you. Yeah, so does anyone have any question.
Yeah, I'll jump in. This is going to be kind of an elementary. Hold on. I'll take these off. That'll help. So this is going to be kind of an elementary question comparatively, because the math stuff is a weakness. But that's why I've really enjoyed reading what I've read so far, because
Thank you.
I really like this emphasis on like sort of bringing Deleuze to the math instead of sort of trying to explain, when Deleuze cites math, what is he doing? Like that's useful as well, but this seems to be bringing Deleuze into conversations where he didn't necessarily go into himself when it comes to modern. So, and it's helping me really think about the relationship. The one thing that I'm still trying to wrap my head around is the sort of discussions with set theory. And I guess it's probably just my really like neophyte understanding of like what sets are doing. So for me, sets are sort of just collections of particular identities. And you said a lot of interesting things about sets that was helping me get out of this sort of understanding and how you were thinking of sets. But if you could, I guess I'm just asking you to say more to kind of help me, because I guess set theory is something that in a very sort of unsophisticated way, I've just been like, well, you can't really do Deleuze with sets. Like, but that's because for me, I just don't really understand set theory properly. But yeah, so that's just a basic.
Yeah, great. So I agree. You couldn't say translate Deleuze's metaphysics into like a purely set theoretical language without really important loss. I think it's because if you look at what set theory does as a mathematics, it renders things in terms of extension, right? An extension in the formal sense of reference, not the like Cartesian sense of like extended space. So a set is what it is because of the members it collects, right? And so a set is what it is, and it's nothing over and above its parts, and its parts are determinately defined sets. So there's no indeterminacy, there's nothing really particularly mobile or dynamic about it. There's nothing like continuity rendered in set theory always seems a little bit illusory. Like you're like just kind of adding sets until it starts to look vague and blurry. But compare this to something like Rocco Gangel's work on Deleuze and category theory, where as a form of mathematics, category theory seems much more dynamic, much more continuous, more geometric, seems to pair better with a lot of the ideas in Deleuze. Though I push back also on the idea of, I'm going to put it, the idea that one could translate all of Deleuze's claims into a completely formal language. The way that like early analytic philosophy tries to replace philosophy with just well-structured formal statements and then logical relations between them. And this, I think, gets to a deep methodological and metaphysical distinction between Deleuze and Badiou, for example. Because Badiou says, okay, we'll take the mathematics as true, and our job is to read the ontology out of the mathematics, right? To grant this and then look at it and say, okay, how does this express being? How does this capture what the deep truth of what there is? Deleuze, on the other hand, I think is explaining the genesis of being as well as the genesis of truth, how anything comes into being. And so mathematics as a thing among others and a practice that humans do, though I do think it gets real truths, you have to explain how it is that the statements of mathematics get their truth, right? Like what makes them able to express something, accurate sounds a little too representational, but I'll say accurate right now, something about the universe. And so there, what I'm trying to do is say, well, if you focus on or extract a certain part of the modal structure of difference, you can see how you get these different formal systems, right? So if you only focus on the difference between the way things are contained, then what you're doing, and you express that, and you express the regularities of that, you will get set theory. Whereas on the other hand, if you focus on the pure differences of how things are related when moving from one to the other or transferring from one to another, you would get category theory. And that different formal systems would be generated like this. So they're getting something right about, so we can both explain how mathematics is the way it is, how it gets the truth it gets, and have some account of what is it telling us about the universe, what are its truths about. And so that's broadly what I'm doing. And the reason set theory has such a privileged position in this book is not that I think it's I don't buy the idea that all mathematics, like set theory is the only foundation of mathematics. I'm a pluralist about that. I think you can do multiple foundations, set theory, category theory, maybe homeotopic type theory, though I don't know that particularly well. But set theory has such a central place here because I'm engaging in a lot of these analytic debates, and I'm dealing with the analytic stuff, and that whenever they're making use of logic or they're making use of possible worlds or they're making use of model theory or anything formal, in the background of what they're doing is set theory. And because of historical reasons, set theory has been privileged in the analytic tradition, specifically because of its use in logic. And for example, the analytic tradition says almost nothing about category theory. So that's why the central place of it in the book.
Yeah, that's really helpful. Thank you. Yeah, and it applies to something that you said that I really, really liked, in that typically when people read Deleuze, they think of it as like, well, the hard part is describing difference. But no, actually, the problem for Deleuze is in a world of difference, how do you explain identity? It actually is the other way around. And the moment I kind of flipped that switch, I felt like I started understanding Deleuze, what he was up to a lot. Much better. So I love that when you said that, because I think so many people get tripped up because they come from the classical understanding and they're trying to get back, and they realize the real overturning is sort of how do we go the other way? You know, we've assumed this is the basic fact, and how do we describe everything else? But yeah, I'll stop talking now. Yeah,
Thank you.
Yeah. Any other questions?
So I think Corey has a question.
Cool. You can unmute yourself, Corey or Arkady.
Yeah, unmute.
First of all, thank you very much. It was an excellent talk, and I really love your work. I really appreciate it a lot. Towards the end, you mentioned something. Oh, thank you very much. Towards the end, you were mentioning logical pluralism. I was just wondering, how does it play a role in your project? Do you think it plays a role also in Deleuze's thinking?
So where Deleuze talks about the calculus in difference and repetition, there's a line, I don't have it to hand, but there's a quote, there's a claim he makes that I think is often underappreciated in the work on Deleuze and mathematics, where he says that dx thinks difference better than, dx formalizes and thinks difference better than a symbol like not a, right? Because not a, the logical negation, is the way it's the way you would symbolize something being different in first order logic, and that turns difference into just pure opposition, right? So what is different from my sparkling water can is literally everything else, and it's just whatever is not included in the set or whatever is opposed to. Dx, on the other hand, is this symbol of infinitesimal differences, of these changes that are too small to specify, changes below the limits of mattering, however you want to interpret. And he says that's a better capturing of difference. But this is a formalization, and it will always fail to completely express difference itself. And he says something about a dialectic prior to difference. And there, I think he's making a clear reference to like Plato and later Plato. And what I take that to mean, and what I take both as what one would, if one is being consistent with Deleuze there, would have to say, and I take this on as my own position as well, I'm willing to defend independently, that one should be committed to logical and mathematical pluralism, because difference itself will be expressed when we express these formal systems. Like that's what we're figuring out. That's one of the things we're doing. If difference delimitates the limits of what can be, and logic is a purely general domain because it's how do you express propositions about anything at all, then logic and mathematics, they will express structures of difference. However, in expressing difference, you are identifying some bits. You are making something stable. You are giving some structure there to make that saying or that expressing possible that is not in difference itself. And so you're always covering over some differences. And so what I read that to be is why I read that to be a defense of mathematical or logical pluralism and not logical or mathematical nihilism. Like, these are true relations, these are real necessary relations, and you couldn't make a formal system that just does anything. These limits are ontological, I think. But the reason that is the grounds of a pluralist position, I think has to be a pluralist position, is because if you make different choices on what to hold stable, you will get different independent logics, different independent ways of doing mathematics that will converge on a lot of things, but they will have different entailments, different logics depending on, do I pick 2 truth values, 3 truth values, an infinite number of truth values? You'll get different theorems in those logics. Do I have the parallel postulate in geometry or not? I get different geometries, but they're all equally sets of collections, let me say, of entailment relations, and so they're ontologically on a par. Some are going to be more useful in different practical situations, but they are all going to be formed by making some choices about what to hold stable, what to identify, what differences to cover over when we express truths about difference itself. And therefore, if we want to learn about, if we wanted to, how to put it? In fact, we can learn a little bit about difference itself if we look at what those different choices do, right? If you hold this thing stable in this logic, but if you reject it over here but hold something else stable, what changes? We learn a little bit about how expression of these things work and maybe a little bit about difference itself. Does that answer your question? Or great.
Arkady, you had a question, I think. You are muted.
Okay. No, just bring a little bit back on this. I think part of the difficulty, and that's an interesting question, which doesn't affect your argument as such, neither did much of my previous question, except certain claims which one make. But it's Deleuze in these aspects which you described correctly, account for really very small aspects of what mathematics does in practice. As Hermann Weyl pointed out long ago, that even the intuition of continuity of mathematics has very little to do with how we understand continuity even in philosophical way, apart from technical mathematics. So in a certain sense, if you talk about Euclidean geometry or non-Euclidean geometry, and it's quite interesting that you mostly refer to early Deleuze, but I think when you think, for example, and that would be kind of my question, of somebody, because I worked on that a little bit, but in general, when Deleuze talks about the role of somebody like Riemann, or for that matter, Galois, or Abel, that has to do with somewhat different aspects from merely logical dimensions of mathematics. It really has to do with what I would call conceptual dimensions of mathematics. And this, I guess, quite crucial for the difference in repetition, that idea of problematic versus theorematic, and using the both Deleuze, both Abel and Galois from that point of view. So I think I wonder if what is your reflection on that aspect of his analysis, including in later works with Guattari, because there, I think, in Thousand Plateaus in particular, you have a lot more engagement with this, which I would call more creative aspects of mathematics, the invention of new mathematical formations?
No, it's a great question. In fact, I'd take there to be broadly three different things I think a metaphysician of math would want to explain. One would be like Wigner's indispensability of mathematics for science. And I kind of gesture that, if I'm going to write 2 more books on this project, that's where I'm trying to end up, is to tackle that. Though I think the answer is pretty general, which is if math studies the structure of difference, difference is also what structures physical reality. So that at least makes some possibility of application there, makes that make sense. But there's dealing with the indispensability question, right? Then there's dealing with, and I take this to be broadly what you're asking about here, which is, what does the working mathematician do? How does mathematical truth get discovered and or created? Is it discovered or created? How does that process work? That I have little to say about in this book, though I hope that to be the next book that I do on Deleuze and math, where I get into both the epistemology of it and how it is that we have access to mathematical truths, or we have access to the conditions to express them. Because I'll admit, in this book, I've broadly said, I want to not talk about mathematics as representational truth. Grant me that it's an example of expression, or truths of expression rather than representation, and I'll give you a non-representational account of mathematical truth. What I haven't explained is, what does it mean for something to be a truth of expression? And so that means asking the question of, how is it that we have access to these conditions of mathematical truth that I've argued for? And how is it that, and what is the process of engaging with that? What is the process of expressing that as a formal system like? That I don't have answers to yet. It's a project I hope to do in the future, ideally next 5 years. And then the third thing would be the project that I took myself to be engaging in this book, which is explaining how we have the mathematical truths we currently have. Right, so if you look at least certain philosophers of math, generally the analytic tradition, and you ask, well, what do we have in philosophy of math? We have the set theoretical universe, and then we have that as the foundation of all other mathematical branches. Caveat, maybe category theory does some things you can't do in set theory, and then they don't really follow that up. And then built out of set theory, you get the model theory needed to do formal logic, and so on and so forth. And so I want to look at that set of truths, which I take to be the paradigm case of, these are the most stable, necessary, unchanging, unchallengeable, maybe truths that at least a large number of working philosophers, mathematicians, and thinkers are committed to. And can I, using Deleuze, using a metaphysics of difference, a metaphysics of chaos and flux, explain why those stable, necessary, unchanging truths are the way they are? And so that was the goal of this project. I would like to move from this to dealing with the questions you asked about there, but I don't have that fully worked out yet.
Okay, well, thank you. That's great. Forgive me, but I have to correct you on Wigner, because he doesn't say indispensability. He says unreasonable effectiveness.
Yeah.
Not quite the same. And he also says, and that I think is crucial, that there is one area where mathematics is totally ineffective, and that's initial conditions.
Mm-hmm.
And that's actually quite crucial to many of these questions. And I do think that in a way, Deleuze or Deleuze and Guattari, in a way, are also quite interesting in addressing where the effectiveness of mathematics stops. Because after all, mathematics is very refined, very old, very beautiful, but ultimately it is quite limited, as I think Deleuze and Guattari show.
Yeah, I agree. I will say, yeah, you're right. I was mixing terminology with the Quine-Putnam indispensability.
Right. Yeah, no, I understand. It was not, I get your point. It just, but I think it's not unimportant, because the difference is really quite crucial, because it implies that the term unreasonable, which is quite interesting in that.
I think that's an important thing to point out. And I would say that what I do think also follows from Deleuze's position is something like what you said about, for Wigner, math is ineffective when it comes to discovering initial conditions, right? And I do think that if you accept Deleuze, if you accept the priority of difference, then you do just have to accept that there's probably some brute facts that won't be explained that then get everything off the ground, which is why if we go back to cosmology, I'm not sure that fine tuning is actually a problem.
Yeah.
But
well, I just hope that some of these logical mathematicians will read your book, but I wouldn't bet my house on it. But that's yeah. Thank you.
Thank you.
Okay, we have 5 more questions. If anyone has any questions, they can ask, or I can have the last question chance because I have a question, like a question comment. But let's see.
Dan has a question. I see Dan raising his hand.
Yeah, please go on, Dan.
If you don't mind, it's just sort of following up on some of these, but so one question, but thanks for coming on. This is super interesting, and it was nice to see your manuscript and read in it. I haven't read all of it, but I was going to ask a question on novelty and the relation between individuation and actualization, but you already answered that early on. But I do have a question sort of on the math stuff and generally how you're approaching it, because Deleuze is so focused on like differential equations. I know there's a famous essay by Russell, I think 1913, where on the notion of causality, and he says pretty much every law of nature we know of now is a differential equation. So I don't really need a notion of causal relations. We need a notion of differential relations. I don't know if Deleuze ever read that, but it seems, like a lot of what he's doing. But, calculus is invented by Newton and Leibniz, and for 2 centuries, people are using it, and, scientific revolution, it's unlocking secrets of nature. And yet it's really at the end of the 19th century, Hilbert and everyone, say, but it's kind of mathematical nonsense. They're infinitesimals, passages to the limit. There are all these notions that don't make sense in mathematical terms, and we need to finally, deal with that. And that's where analytic philosophy goes. It has to do with the foundations of mathematics and trying to get an adequate mathematical understanding of things like the calculus, even though the calculus was working, and people were using it long before they discovered the foundations. And even though they get rid of infinitesimals, then like Robinson, gets non-standard analysis and resuscitates infinitesimals. So they're kind of these 2 sides of calculus. One side is it's working, but it's not grounded. And so the analytic stuff that you're dealing with in set theory becomes a ground. And I just wonder how Deleuze seems to go with the first, much more the metaphysics of the calculus and how it, fits with reality. And you and analytic philosophers are interested, or at least there's a side interested with set theory and the foundation. So that's the first question, like how you see that, the relation between those 2. And the second is focus on the truths of mathematics, because I know one of the issues Deleuze poses in Logic of Sense is precisely this relation of expression. And it's almost this question like, well, truth means you have propositions, and somehow they're true because they denote, they refer to, they correspond to reality. But even for the notion of truth to get off the ground, you have to explain how propositions got separated from reality in the first place, so that there's this relation of reference or denotation as such. And that's part of one of the questions Deleuze asks. And, few analytic philosophers ask that question. Just presume you can start with well-formed propositions in English, usually indicative sentences, and that's where philosophy begins. So I wonder what you'd have to say about that. And then sort of a third question. At one point you talk about the genesis of causation and use the term property, and you're kind of engaging, which is great, with analytic philosophers. I sort of agree with Arkady. It'd be great if they read your book, because I think it would help change philosophy. But at the same time, Deleuze rarely uses the terms like causation or property, and he occasionally uses essence and ideas, but he says, but of course, you have to use them in a new way, as you yourself say. That's what you're trying to do. So then the third, more general question is how you see the relationship between Deleuze's metaphysics and then trying to make it, engage with the metaphysics that precisely, he's trying to break from in some way. And I don't know, that's a more general question of how, you get these 2 traditions talking, I guess.
Yeah, those are all excellent questions. And I don't know if Deleuze read that essay by Russell, but we do know that Deleuze read a decent amount of Russell. There's all the stuff on intensity and the references in Logic of Sense. But yeah, I need to check and see if he ever references that one specifically.
I've looked and he hasn't, but as you say, he was a fan of Russell, so maybe he read it and just didn't cite it.
Yeah, which is not out of character, right?
Right, exactly.
So, okay, if I've got these right. So there's a question about, yeah, you can very clearly see set theory and something more like the calculus before it has its foundations as something like the distinction between major or royal science and minor science, right? Like a major or royal mathematics or a minor mathematics. What I, in some sense, what I want to say here is very similar to what I just said to Arkady when he was asking me about like how do you explain what the working mathematician is doing. Is I took these as I take set theory and I take formal logic as not things I think are particularly privileged for understanding the world. You know, my background, at least in undergrad, was physics. I tend to think, okay, the math you use there, like you don't learn set theory as a physicist. It doesn't help you make sense. Or you learn calculus, you learn calculus 2, differential equations, and so on, right? Because that's the mathematics of the physical world. But if I'm looking for what are the what is someone going to challenge this Deleuzian picture of the world, this Deleuzian metaphysics with, it seems like the go-to thing would be, well, if you look at set theory, so you say that if you're willing to be a mathematical realist, which I am in a certain sense, then they'll say, well, okay, mathematics is grounded in set theory. So then you've got all of these stable, unchanging relations between sets. You've got the universe of sets. You've got all of these, you've got an infinite number of unchanging, eternal, necessary truths that do not describe a dynamic universe at all, that describe an incredibly static picture of whatever it is they're talking about. And then the claim that, well, this is fundamental to the math, so this must somehow be fundamental to reality or our description of reality or something. And so my focus and interest there is in showing that no, that's not actually the inference. That you can have a more dynamic view of the universe, you can have the foundation of difference, and you can say the mathematics that is more useful and is more ontologically, metaphysically relevant is actually mathematics like calculus, which is probably my stance. But we can also explain why you have set theory as what you have, and it's you have to give some account of how exactly it gets abstracted, how exactly you get that form of expression based on this much more dynamic thing. So there, in a certain sense, it was looking for what I thought was the hardest challenger to explain, rather than what I thought was most mathematically important to actually capturing what the universe is like, or actually describe what the universe is like. As for propositions and how you get them, again, I think that's absolutely a question, because what is a proposition? It is, well, there's 1,000 different views. Like Frege specifically wants to say that propositions are somehow a third type of thing separate from both physical objects and thoughts. And there's just like this world of the proposition. You have various people who want it to be a linguistic entity of some sort, and so on and so forth. Personally, I think a proposition, and this will be maybe a broken answer, or a broken record sort of answer, propositions are things, they're objects, so their explanation of how you get them are going to be broadly a story of individuation. And generally what I take propositions to be, and I think that you can pull this somewhat from Deleuze's work in logical sense, is you have sentences in a natural language, and then you define an equivalence class over those such that these sentences we're going to say are all true in the same situation and they're all false in the same situation. And that equivalence class is what the proposition becomes. So it's just defining an identity over more complicated, over a more complicated language. You're taking natural language, you're covering over a bunch of the differences. You're only leaving unveiled what can be expressed through like a binary or trinary notion of truth, or however many truth values you have, and you're stripping everything else out of the language. So broadly, my explanation is there's a story of how you cover over the differences inherent in natural language to get something formal like the proposition. And I'm sorry I wasn't able to write it down fast enough. What was the third question? property in the relation to terms and like terms.
A more general question, just about metaphysical terms that Deleuze just
Yeah.
doesn't use, terms like causation and property, and seems like his metaphysics is moving somewhere else, getting them in conversation.
Great. And again, this is, I made a certain methodological choice with this book that I'm open to critique on, and maybe is something I'll revise in the future and do it a different way. But what I wanted to do here was see if I could make the case, or make Deleuze's case, like reconstruct this metaphysics in as mainstream or as analytically acceptable terms as possible, in a way of sort of taking those terms to have a wider or different use than they usually have, right? So I use the term eternity, but what I mean is anything that is grounded on the conditions of time, not something that will exist forever, or something that would exist somehow transcendent. I use the term essence broadly the way I think Deleuze uses it, which is somewhat of a synonym for multiplicity and all of that. And the reason behind this, I think, is because we very often, in the continental tradition, have these words that are the classic words that philosophy gets done in, and we want to throw them away. And our favorite authors invent all these cool neologisms that we like to use. But we end up flattening those classic terms and forgetting the fact that those terms are the things that people have been fighting over. They're not simple one definition phrases that everyone agreed on. Like essence broadly has this idea of it's going to answer the question of what makes a thing the thing that it is, and not something else. Or what is it that in order to be properly conceiving a thing, you must conceive. That is a term that is denoting a debate as much as it is denoting a static concept. And so by taking multiplicity and saying, this is a thing that answers the question of how do you identify something over time in a metaphysics where difference is primary, so where identity isn't given but has to be produced, that's a new answer to the question of an essence, to the question that essence asks. So that's broadly what I was trying to do. That was if I'm using a word like property or essence or eternity, or one of these more words that you wouldn't see as a neologism, and then applying it to Deleuze's metaphysics, I'm trying to take his answers and his account and show how they are answers to these more classical problems. And so in that sense, do make a claim, or can claim these as its own terms, or as a new answer to those problems. Does that broadly make sense?
Yeah, it's fantastic. It's very Deleuzian in some way. Like, yeah,
I value the agon.
Yeah, yeah, perfect. Thank you. That's
Thank
great.
you.
Okay, that's great. Aryan?
No.
We cannot hear you. Maybe you can type your question and I can read it, Aryan. Okay.
That's one question while Ariane's typing. One more.
Sure.
So I wonder what you think of this. I read there's this guy Dieudonné, a French mathematician who was kind of the driving force behind the Bourbaki group. But you know, I remember reading, and it struck me. He's, you know, foundations we think are, you know, where you start, and then you build upon the foundations. But he says, in fact, in mathematics, it's the opposite. Foundations come at the end. You know, there's a problem with you know, foundations of the calculus. Cantor does set theory, but he doesn't derive set theory from axioms. It's Zermelo Fraenkel come, you know, after the fact, try to say, what are the presuppositions of this domain of set theory that Cantor's developed? And then they formulate axioms and the various other axiomatic systems, even for set theory. And now maybe category theory is another way, you know, whatever. But, you know, the language makes it seem like foundations are the rock bottom, you know, that things start with. And his point was, no, they're kind of the last thing that people get around to in math. It's like the law and order people, like the police come in and say, okay, we got to clean up the situation here and see what the hidden presuppositions are, and like set theory that Cantor himself wasn't clear about, which kind of inverts how we often think about mathematics. I wonder if you share that in sort of the way you're approaching things, because you're sort of trying to, you know, connect the unchanging nature of mathematics with its dynamic status.
Yeah, great. Yeah, I mean, I think there's a very practical upshot of that, which is we teach math in incredibly poor ways, because, you know, we teach math as if it's the problem of using readily established truths that we don't know how we got. They're just given from on high, and you just crank out or calculate an answer. Whereas, you know, like what the process of actually doing math and what mathematicians do is exactly that. Seeing formalizing systems, seeing once you have the formalization, what else does it need to make it well behaved? What presuppositions or axioms are at work? Can you challenge those axioms? Can you do it in an alternative way? Are those alternative ways actually secretly the same? And can we prove they're isomorphic? All of that stuff, right? As to that question, well, I want to approach this stuff as a metaphysician, right? So, you know, Deleuze says, like, who cares what I say about mathematics, as long as I talk about mathematics as if I'm a dog, right? It's like, I'm not an expert here, so I'm not going to tell the experts how to do this. I'm going to try to learn from them and make it useful for what I do. And it's interesting that you go back to Aristotle, and he says, we've always got this question of, do we work from first principles or to first principles? And I think you have that, as much as you have that in mathematics, you have that in metaphysics. And I see the project that I'm doing as taking what are currently accepted paradigms of mathematics. And in the book, I try to look also at some like stranger logics and some other attempts at doing math, like Grice's negationalist mathematics and all that, and then try to argue to the metaphysical first principles, or rather show that Deleuze provides the metaphysical first principles that would explain why we see these strange and interesting facts of mathematics that we do.
Yeah, great, thanks. Yeah, I'd like to hear more about Grice's stuff, but that's a whole different conversation. So.
Corey's also a great place to go for that.
Thanks.
Okay, let me read Ariane's question. Ariane says, I just wanted to ask a clarification question. What do you mean by contingency, i.e., in that dispositions are contingent? Because talk of dispositions or powers seems to want to say something slightly stronger than mere contingency. Example, if a glass fall on the ground, saying that it's breaking or not breaking is contingent seems to be something like saying that whatever happens depends on circumstances. If the floor is made of stone, the glass breaks. If the floor is made of rubber, it bounces, etc. If one says that the glass is a dispositional entity, an entity disposed to break, then it seems you are making a stronger claim.
Yeah, okay, great. In general, when I'm using disposition, so in some sense, this starts with me ceding some ground to the analytic conversations that I'm engaging in, which is, for the most part, when analytics are talking about modality, they're just going to talk about necessity and possibility, and everything else is going to be in those terms. Sometimes they'll accept counterfactuals as a different category separate from those two in some interesting ways. And counterfactuals are usually taken as related to dispositions, right? So when I'm using contingency here, I'm strictly meaning it as not necessary. So just can be taken apart, can cease to exist, is not part of the fundamental furniture of the universe, that it has a birth date and a death date, right? So one day it wasn't once and it won't be again one day, and it didn't have to be here in the first place. That's broadly, I just mean that by contingency. I do agree with your example that what you're getting at there is there is also another type of relative necessity relative to like what it is to be the glass. And that is the case where the glass itself is contingent, but that it's a glass means it's not contingent that it's disposed to break in certain circumstances, right? And so that would be, if they were going to make a modal difference there, that would be the difference. That would be saying that's an essential property or that's a part of the glass's multiplicity. You know, there's something about the identity of the glass in that category as the type of thing it is that guarantees that dispositional property. And so there, I would say, yeah, it's sort of a second order, it's sort of a first order distinction versus a second order distinction, right? So because I'm ceding some ground to the analytic conversation, I'm willing to talk about the difference between essential and accidental properties, though I think that, you know, Deleuze put some interesting challenges there. But that would broadly be what follows from a thing's multiplicity and what doesn't. But even something's multiplicity at that second order, that's contingent because that thing didn't need to exist. That identity didn't need to exist, right? So if I'm going to say a theory of historical essences means just what essences there are, what multiplicities they are, that is a historical fact of the matter. Had things gone different, there would have been different multiplicities, there would have been different essences. Means that even that is ultimately contingent.
Thank you.
Thank you.
That's great. I think we are out of time. Thank you, Mike, for this great presentation and great discussion. Like, thank you all participants. I really enjoyed the discussion. And like, I'm officially ending the session, but if you want to stay, like, I don't know if Mike, if you want to stay and if anyone has
Try to stick around for a little bit.
questions, yeah, like you can.
Great, and thank you everyone who attended.